We begin Cisco 2 Summer 1 2020 with Module 14. In Cisco 1, you were introduced to the OSI and TCP IP models of network communication. You started with the physical layer where information flows in bits across the media. You learned about cables and cable construction. Moving to layer 2, the data link layer, where frames are the protocol data unit, you learned about switches, MAC addresses, or burned in or physical addresses. Layer 3, the network layer, you learned about routers and logical or IP addressing. We spent considerable time in modules 11, 12, and 13 practicing IP addressing of devices, subnetting, and beginning router configuration for both IPv4 and IPv6. That brings us to Module 14, the transport layer, Layer 4. You have assignments to read the sections of this module, so this video will not be a word-for-word look at that content. My intent is to point out most important points and emphasize key elements and practices in the module. The transport layer handles communication between hosts, linking end users with the lower layers for transmission. This is where the data is broken into manageable segments for transmission that will be reassembled at the destination. As you read the chapter, take note of slide 14.1.2 and click on each of the 5 buttons describing the responsibilities of the transport layer. Note the term multiplexing. You'll see this often, meaning that more than one stream of data is handled at a time. The last layer used the IP protocol. This protocol is concerned with where the conversation is going. Now here in the transport layer, the concern is how it is moved. For this, there are 2 protocols, TCP and UDP. TCP, Transmission Control Protocol, provides accurate, reliable transmission of data. It ensures a connection before data is sent, keeps track of the correct order, as well as the receipt of the segments. UDP, User Datagram Protocol, provides basic fast delivery without accuracy or assured delivery. It is best effort. I like to call it the I don't care protocol because no connections made. The information is simply received and sent right along. This may remind you of cut-through switching from layer 2. UDP is used in delay-sensitive applications, most notable voice and video. If these applications had to wait for an established connection and acknowledgments, they would require buffering. Nobody likes buffering. If you're streaming in an environment, some packet loss can be tolerated. It would be barely noticeable. Buffering would be much more noticeable and annoying. As you read more detail about TCP, take note why it would be the preferred protocol for data such as email or file transfer. It ensures accuracy and that no data is lost. The how of transmission is contained in the header that is put on each segment. Note the various fields. The next slide defines these fields. Be familiar with those terms. You can see here the applications that use TCP. HTTP, which is for web pages, FTP, file transfers, SMTP, simple mail transmission protocol, that's for email, SSH, which is for encrypted remote access. Accuracy is important with each of these. Moving on to UDP, it is characteristically simple. Note these features. This is the UDP header. It is much simpler than TCP. Notice source port, destination port, length, and checksum. Compare this to the header of TCP. This slide reiterates that voice and video are prime candidates for UDP. So are applications that are simple requests and replies, such as DNS, Domain Name Service, and DHCP for automatic addressing. Note this last bullet point. UDP is characterized as unreliable, but the applications themselves can handle error detection and recovery. These examples include SNMP, which is a simple network monitoring application, and TFTP, which stands for Trivial File Transfer. This slide is not in your chapter. It's my comparison of the two protocols. Both divide data into segments. However, the difference is in how those segments are moved. How does the transport layer keep track of multiple conversations? Recall the term multiplexing. Enter port numbers. Recall that both the TCP and UDP headers start with source port and destination port. These ports are placed in the segment to identify specific locations or conversations. Know this term, socket. Socket is the combination of the source IP address and source port, or the destination IP address and the destination port. It is written as the IP address and then a colon and then the port number. We will deal mostly with well-known ports and registered ports. If you will remember the range of well-known ports, you'll be able to recognize what is a socket using a registered port or one that is using a well-known port. This is a chart I worked up for reviewing well-known ports. It's not in the chapter this way, but knowing these ports is important. I have seen these asked as parts of job interviews or job interview testing. So looking here, we have these well-known ports, 20 and 21, file transfer protocol, both data and control. Those are both part of this application, and they use TCP for accuracy. You want your files to be accurate when they are transmitted. 22 is SSH and 23 is Telnet. These are both remote access applications. You want accuracy when you are remoting to another device to do configurations. TCP is used here. SMTP, this is Simple Mail Transfer Protocol, and that requires TCP. This is used for outgoing mail, and it is port 25. Its companion is port 110 POP3, which is a mail protocol that's used for incoming mail. So they both use TCP. DNS, domain name service, can use either one, either UDP or TCP. 67 and 68 are DHCP server and client. They are simple request and reply, so they use UDP. We mentioned TFTP trivial file transfer protocol. It can use UDP because it is a simple application. Port 80, one that will be encountered often, is for web pages, hypertext transfer protocol. That's what's used for web pages. It uses TCP, and its companion is 443, and that is HTTPS, which is secure websites. And then 161, 162, SNMP, which is a monitoring protocol, very simple back and forth message, and it uses UDP. You'll see there 179, this is one I put in for my Cisco 4. It's a routing protocol that is used across independent networks, and it uses TCP. Here is a more linear list of these, and you'll see that in your chapter. NetStat. NetStat's helpful for identifying ports. I'm going to depart from the PowerPoint for a minute and bring up a command line. You can do this on your own computer. I enter the NetStat command. Notice here you have source ports and destination ports. It has listed the source ports by number, and these are fairly random. And you'll notice they are in that range of registered ports. And then the destination ports, notice all of these HTTP and HTTPS designations after the colon. These would be ports 80 for HTTP and 443 for HTTPS. One reason you're seeing so many of these is I happen to have several web pages open, and they're sending and updating information all the time. Yours may look different when you do it on your machine, but it's an interesting way to see what sockets are there and what ports are open. I conclude the video here, and the next video will begin with 14.5, the TCP communication process, which is also an important point that I have seen people quizzed on in job interviews.